All right, hello and welcome to MCR4 Unit 1, Day 4. So today we'll be talking about solving equations with fractions and kind of going on to that route. So when you have fractions in any type of an equation, like this x divided by 5 minus 3 equals 10, what we can do is we can use the least common denominator, which in this case would be 5. And that would end up doing something called fraction clearing. Now, if I look at this problem as is first, though, you don't have to do anything with it. You could just say, well, I'm going to add 3 and cancel that out and get x divided by 5 equals 13. And then you could multiply by 5 and get x equals 65, which would work just fine. But what if there were multiple fractions in there? So the technique I'm going to show on this is called fraction clearing. First, you would grab the least common denominator, the smallest number all the denominators go into. These are ones. So between 1 and 5, your least common denominator would be the 5. And my tip is always grab the biggest number and see if the rest go into it. So now what we could do is multiply every piece by the 5. Clearing any fractions. That would give 3 times 5 is 15, 10 times 5 is 50, and now when I add it, I get x is 65 as well. Again, which technique you use is up to you, but the fraction clearing works really well if you have multiple fractions. So if you want to do the LCD method, you first find the LCD. Like I said, I like to look for the biggest number and then use that to find the rest. Then we multiply all the pieces by the LCD, distribute, collect like terms, and then you're always trying to get that variable by itself by undoing via order of operations. So to do it this way, we have one like x over 5 equals 3 over 10. All right, so I'm going to look at it and say, what's the least common denominator between 5 and 10? And let's focus on the 10. 5 goes into 10. So that's my least common denominator. Don't work too hard on this. Then we're going to multiply the 10 on each side. And if there were pluses and minuses, we do it there too. So 10 divided by 5 gives you a 2 and leave the x alone. This 10 cancels, so you get a 3. Then you finish off by dividing. Were there other techniques? Sure. Do you have to use this one? Nope. Use whatever you feel comfortable with. So for question 2, my numbers are 2, 3, and 6 for my denominators. So 6 is the biggest number. 2 and 3 both go into it. So I'm going to use 6 as my number. So I'm going to multiply each piece by 6 all around. So that gives me 6x minus 6 times 2/3 equals 6 times 3/2 minus 6 times 5/6. So notice it's still like the original x, 2/3, 3/2, 5/6, but I put a 6 with everything. So now when I go to clear it, the 6x does not clear, but the 6 times 3 turns into a 2, and I still have the original 2. I'm going to leave the 3. The 6 times 2 turns into a 3, and the 6 divided by 6 just leaves the 5. So do that nice and slowly so that you don't leave any of your numbers off. So that gives me 6x minus 4 equals 6 minus 5, 9 minus 5, I'm sorry. So 6x minus 4 equals 4, plus 4 on both sides. I'm going to shoot up here. That gives me 6x equals 8. And finally, 4/3 for x. Whew, that was a bit of a long one, right? All right, now would be a great time to pause the video and try question 3. And then I'm going to do it as well. So for question 3, you've got a 2 and a 5. 2 doesn't go into 5. So I'm going to look at the multiples of 5. The next one is 10. 2 goes into 10, 5 goes into 10. So that's the least common denominator. So I'm going to have my 4x over 5 minus my, you know what, I might run out of room here. Okay, so I'm going to have my 4x over 5, and I'm leaving some room. Okay, because what I'm going to put in front of each one is that common denominator. So 10, 10, 10, 10, 10. And hopefully this will go correctly and we'll end up dividing out all our fractions. So 10 divided by 5 is 2. Leave the 4x. 10 divided by 2 is 5. Leave the x. Equals 10 divided by 2 is another 5. Leave the 3. 10 divided by 5 is 2. Leave the 6. 10 divided by 5 is still 2. Leave the 3x. So this turns into 8x minus 5x equals 15 minus 12 minus 6x. All right, now the next step is to combine all those like terms. So 3x equals 3 minus 6x. I'm going to move the 6x over. So that gives me 9x equals 3. We're so close. That gives us x equals 1/3. I know it looks like a lot more work, but it actually is not as much work as if we did a different method. So that's your fraction clearing. All right, go down and try questions 4 and 5 now. Which are down here, but then I also want you to look at the special type these are. If it's a fraction equals a fraction, and there's none of the plus minuses like there was up here, we can actually take a little bit of a shortcut that's called cross multiplication. So it can only work if you've got a proportion, which is a ratio equals a ratio like this one. And what you can do is create this cross multiplication piece, which takes the top of one to the bottom of the other, bottom of one to the top of the other. And then it gives you a little bit quicker way to solve problems that are like that. You can still do the fraction clearing, but you can also do cross multiplying. So the gist again, to highlight this, is if it's a proportion where A over B equals C over D, you cross multiply them and get AD equals BC, and then solve for your variable. So when you go down to do questions 4 and 5, you can fraction clear with the least common denominator, or you can absolutely do cross multiplication. So choose whichever method you want, pause the video, and then come back and see the answers. So I'm going to choose on these to do cross multiplication. So I'm going to do 7x equals 21 times 6, and then divide by 7. You can type that right in. So that's x equals 18. Then for this one, we're going to do 2x times 14 equals 15 times 2. So that actually gives me 28x equals 30. Divide by your 28. And then reduce that fraction down to 15 over 14. And I do that by dividing each of these by 2, as long as I do it on top and bottom. All right. Next one then is if we want to solve equations with proportions. So if we have the two ratios that are equal, they're called a proportion, they're proportional. And we're basically writing this proportion in different ways. We could also do 6/15. So we can write them, we could do 20/50. All of these are proportional. So a great thing to do would be to solve it with cross multiplication. So then just really highlighting this idea of what cross multiplication looks like. It would be the 12 times the x equals the 3 times the 4. So it's going to be the one without the variable gets multiplied, and then you divide by the number that you didn't use. You can type all that directly in. So again, it's going to end up being the two numbers that don't have the variable multiply, and then you divide by that final number. If you like it fully written out, by all means do that, but it's the same process. Okay, and on the calculator over here, you can type it as 3 times 4 divided by 12. You can type that directly in that calculator. So then next we have some word problems with proportions. I'm getting into the heart of that. So if a recipe is 2 eggs for 3 cups of flour for 4 servings, we now want to ramp that up and make 6 servings. So how many eggs, how many flours do we need? So for the eggs, let's set up our proportion. We need 2 eggs for 4 servings. So how many eggs do we need for 6 servings? And now we can do the cross multiplication. When I say make sure the units match, eggs to eggs, servings to servings, recipe 1, recipe 2, we need to be able to write those in a way that makes sense. So that's 2 times 6 equals 4x divided by 4. So we end up needing 3 eggs. And then we can do the same for the flour. We need 3 cups of flour for 4 servings. So how many cups for 6 servings, and then cross multiply. All right. When it's a percent problem, we can set it up the way we've been doing what is of with the math, or you could set it up as a proportion. So when it says 60%, you automatically set that up as 60/100. N is the percent, 100 is the 100, because that's what a percent is divided by. And then this is my amount and my base. So if 60% of a number is 20, what's the number? This is the part, the whole. That's another way I think of it. Part whole equals part whole. And then I can go that way. So for question 8, read it, try it however you want, then come back. So if Joe saves 5% of his monthly salary, that's automatically 5 out of 100. And his monthly salary, the whole, is $1,500. How much does he save? Another way to say this would be 5% of 1,500. If you look, it's the same math that you end up doing, because this is 5 times 1,500 equals 100A divided by 100, which is the same math. So no matter how you slice it, Joe is saving $75 per month out of his paycheck. All right, and then our last item for today is a little bit of looking at scale factors. So if you're told something is a 2-to-1 ratio, that means this is 2 times the size of that one for each measurement. So if this is 0.5, the corresponding one is 1, or 0.5 times 2, which is the scale factor. If this is 1.5, the corresponding one is 1.5 times 2, because that's the scale factor. So all of them are double. So if I go down here to an airplane, say a model is 1 to 144. So that means the actual one is 144 times each measurement of the model. Or the model is 1 divided by 144. So if the actual is 240, then the model would be a 1/44 scale. Does that make sense? All right. And then finally, we also might use it in blueprints. So if this is a blueprint of a room, we want to draw this of a house layout. We want to draw this smaller. We don't actually want the full size. So what you might do is, what were the original dimensions of the house? And I'm just talking the length and the width here. So this one on the drawing is 4.5 inches, 1.5, 1.5, 1.5. This one is 5 inches. And it tells you every inch is 6 feet. So this is 4.5 inches. And then 1 inch is the equivalent of 6 feet according to this scale. So essentially we're multiplying by 6, but converting the units. So it ends up being 27 feet if you do 4.5 times 6. And then the other one was 5 inches. 6 feet is 1 inch. So cancel that out. And the other unit was 30 feet. All right, you now want to go and complete assignment number 4 and have a nice day.